Hello and welcome to the 22nd episode of the Pepper Podcast. For those who are returning, welcome back. And if you are new, the Pepper Podcast covers a wide range of spicy events that occur in our daily lives. Two high school students tackle heated topics through discussion. I'm your host, Jay Mehta, and joining me is my co-host, Andy Watson-Pen. And today's topic is centered around space junk and its disastrous effect on extraterrestrial space. So most space waste is concentrated in the skies rather than the stars and planets, which is including over 8,000 metric tons of waste. And as of January 2021, the U.S. Space Surveillance Network reported 21,901 artificial objects in orbit above the Earth.
Yeah. So I think it's really important that we first define what space junk is, right?
Yeah.
So space junk or space debris is any piece of machinery or debris left by humans in space, and that could be from, as you said, like rocket launches, satellite launches, telescope launches. James Webb.
Yeah.
All that has space junk as a byproduct.
Yeah.
And I like the statistic you cited. It's a lot, like a lot of space junk.
Yeah.
And this space junk, it's not just floating there, right? It's moving at super high speeds, like about 15,700 miles per hour or
Yeah.
25,265 kilometers per hour in low Earth orbit, which could cause significant damage to satellite spacecraft when it collides with it. Like I know there was a story when I went to this lecture. I don't know, it was a lecture, yeah, and it was like a little piece of paint, a little chunk of paint. They were the astronauts that were in. It was like a space station or a space shuttle, one of the two, and they were in space. And all of a sudden, they heard a boom.
Yeah.
And then they looked at the side, and there was a huge dent in the side of their
glass.
in the side of their vesicle. Yeah,
Yeah.
the glass. Yeah. And it turned out to be just a little piece of paint or a
Yeah.
little piece of metal.
It was literally a drip of
in
paint.
space, left over from some past launch.
Yeah.
And if that little tiny piece can do that much damage, right? Imagine how much a bigger piece, like the size of your fist, a tennis ball, a basketball, that can cause insane damage to not just people, but to like the spacecraft and the equipment and a lot of knowledge that could come from, space exploration.
Exactly. And like I'm glad that you mentioned that like yes, space debris does include most of this like satellites and these rocket launches, abandoned launch, like the launch vehicle stages, and then like the rockets and stuff. But really what is the most is these like small tiny flecks of paint that chip away from these like spacecrafts and the satellites. And so that number that I said, the 21,901 artificial objects, are just the
Right.
ones or the objects large enough to be tracked. So as
Right.
of January 2019, more than 128 million pieces smaller than 1 centimeter and about 900,000 pieces of debris, like around 1 to 10 centimeter, around 34,000 pieces of larger than 10 centimeters were estimated to be in orbit. So that's just an estimation, right? We can't exactly like plus or minus give a few, but if a bullet-sized hole in glass can be done using a literal drop of paint,
Yeah.
what's stopping something bigger, like you said, like a softball or a
Yes.
tennis ball or something even just bigger, like, or even like a piece of hail, almost like that size, that would cause extensive damage, right? And so the most expensive thing that we've ever purchased is the ISS. And so it's helped a lot for, international travel, not international, like extraterrestrial travel. And so the space station has endured a little bit of complications with, some debris hitting the space station and other sorts. But we have really polluted our space. And it's not really talked about because, I mean, nobody really goes around and talks about how space is so polluted and there's a
and
lot
like
of
how space is an environment, right?
Exactly,
Like we do on
yes.
Earth. Yeah.
It is its own environment, and like we're
Right.
taught to believe that, right, space is infinite, and which it is, right? But we have to remember that there's a space around the Earth that is extremely, extremely clouded with the amount of material that we've produced. And so, just looking at the history of it, it started, and the amount this like 18,000 metric tons of waste started less than 70 years ago. In
Right.
1957, the first artificial satellite sent to space, which is the Sputnik 1.
Right.
Um,
Right.
Ever since then, debris has quickly accumulated since then. It's exponentially grown into what it is now. And it's continuously growing, right? And we haven't, because you can't really go out and clean it up or anything, right?
Right.
Considering it's so fast. So the best thing that we can do, right, to mitigate anything is just calculate the trajectory of you not hitting it, right? And so
Mhm.
it's very difficult for people nowadays to kind of adjust, right, for this extra amount of debris that's there. And
Yeah.
with the increasing amount of I guess these missions that these countries are having, and I know NASA hasn't done one in a while, and with the satellites that are being sent to space and everything, we're continuously polluting, creating a bigger, like junkyard, just
Yeah.
right outside. And like I said, right, it's not just mainly outside, like in space, what's what we define as space. It's in our skies as well. So there's a lot that's in our closer range, right? Not the blue sky
Right.
that you can see, but a little bit above it, right?
Mhm.
It's there that's really where it's bad. And
Right.
a lot of these, I guess you can talk about Andy a little bit later. Like a lot of these are like satellites are dead.
Right. Exactly.
So I mean, yeah, if you want to go for it, or I can.
Yeah. Yeah. I can do that. So, there was one instance of like uh, a dead satellite from Russia colliding with another satellite in the atmosphere, and like it literally exploded like in the
Wow.
sky. So it really puts into perspective. It's kind of a constant reminder to scientists that maybe this is a like a problem that we need to focus on. Like for example, according to the Natural History Museum, there are 2,000 active satellites in Earth's orbit, but 3,000 dead satellites. Okay? And so there is a 1 in 10,000 risk of collision that will require debris avoidance maneuvers. How,
Yeah.
though that may seem small, as time goes on, that chance gets even smaller or even bigger to like for a collision, right? Because as more space debris is put into space, it just increases the amount and the likelihood. So additionally, like collisions are rare. Like a Chinese satellite, for example, another broke up in March 2021 after a collision that it had,
Yeah.
and previously the another when a collision happened before that was 2009. So yes, there's 12 years apart, but the chance of you know somebody maybe being aboard one of these satellites or aboard a space shuttle and it colliding, that would be devastating. And it's not just the loss of human life or the effect it has on like data, it's also economic.
Yeah.
Right? At the end of the day, NASA is an organization, and money is a big fuel for space exploration and
Mm-hmm.
seeking of knowledge of our own world.
Yeah.
So, like that one thing we were talking about, like it can cost up to $50,000 to replace one window for a NASA shuttle.
Yeah.
Like, $50,000 for one window, which that's a lot of money.
Yeah. It is.
But so it's really like it's really difficult to kind of get all that debris out. Like we can go to space and kind of get that debris because when you go to space, you also leave behind space junk. So
More
it's kind of
debris.
like a
Yeah.
net, yeah, right. So it's like a net zero gain. Like
It's
you're
a
not really
perpetual cycle, isn't it?
right. You just
Yeah.
keep going, and then like yeah, it's a really complicated issue
Yeah.
and something that we I think as a people need to focus on more if we want to focus more on space exploration and stuff like that because that can pose unforeseen dangers to not just the Earth and astronauts, but also contamination of other planets and other
Exactly.
systems, you
Yeah.
know? Yeah.
So there's been like just going off that, there's been like space junk that's been found on the moon. So like things have
Right.
reached the moon, and it's definitely had effects around. So like just I pulled up some data about the ISS. So over the station's 23-year orbital lifetime, there have been about 30 close encounters with orbital debris requiring like evasive action. So like of course if they detect some debris coming, they try to remaneuver the ISS to avoid it. But three of these
Yeah.
near misses occurred in 2020, so there's more increasing amounts that are happening recently. And then this year there was a hit. So like a tiny piece of space junk punched a 5 millimeter hole in the ISS's like Canadian built robot arm. So in the Canadian built robot arm, there was a 5 millimeter hole that made it a lot. It required a fixing of it, of course. But it's
Hmm.
very, like you said, $50,000. It's not cheap. It's very, very
Right.
expensive
Right.
to continue to replace these, like just
Yeah.
these things. And did you mention the China 2007 anti-satellite test?
No.
So
You
the
can.
so China's
Yeah.
2007 anti-satellite test used a missile to destroy an old weather satellite, and it added more than 3,500 pieces of large trackable debris and many more smaller debris to the debris problem. So another thing is like the legislation factor of it, and like the controlling of space extraterrestrial like factors
Right.
and regulation. It's very hard because space is not owned by a country. It's very hard for enforcement, law enforcement and such, to happen in
Right.
that space. And so I mean, of course there are formalities and such, but nobody's going to stop like a country like China to blow up, a satellite, right?
Right.
And of course, now that we know that you shouldn't do that, of course, nothing's happened since then. But I mean, a piece of space debris can reach speeds up to like 4 to 5 miles per second, right? So
Yeah.
that's 7 times faster than a bullet, and the equivalent about being hit by a bowling ball moving at 300 miles per hour.
Yeah.
Yeah,
Yeah.
it
Uh,
it hurts, right?
Yeah,
And
like you
so
were talking about, like China exploding their satellite. Uh, sorry, there was some another thing that Russia also did it, and the satellite they exploded. It was launched in like 1982, I believe, and it weighed 4,410 pounds.
oh wow.
Right? And it created 15,000, 1,500 or 15 1,500 pieces of trackable space junk. And a space junk that's trackable, as you said, doesn't include like screws or tiny things that can't be tracked.
Yeah.
Pieces of paint, pieces of shrapnel. It's only like really larger pieces, like that are like the size of a softball, that really do cause problems. And it was like exploded at the height around 50 miles away from like the some other active satellites. So the risk of the active satellites coming into contact with that debris is was calculated to be about double.
Wow.
Yeah.
So like on top of that too, like we talked about earlier, like about the amount of satellites that are still working, right? So we sent
Mhm.
these satellites to space to temporarily, help us out with
Right.
tracking the weather and such, but only right now about like 1,800 are still working. So there's 4,700 satellites approximately still in space, but 1,800 are still working. So that's not a super, super great proportion, right? That's less than a third.
Mhm.
Or
Yeah.
it's a little bit more than a third. So what really, I guess like what people have been wondering is like, what are we going to do with the rest of it? And the answer is you can't do anything about it. The space junk
Right.
has been, you know, set is put into the extraterrestrial space, and it's going to remain there, going 15,700 miles per hour, until it eventually collides with something, right? It's very, very difficult. However, and I'll get back into it later, some scientists successfully tested a net to help snag orbiting debris and burn it in Earth's atmosphere in September of 2018, and it was successful. However, it only can snag very small debris or like smaller debris and not these
Right.
large sets of debris. And it's not a whole lot that he can kind of grab or been tried to like remove from the area.
Yeah.
When it's shot out, it only grabs like I can find the exact number about how much it grabs, but
Hmm.
it's very difficult to continue to just pull more out. And the satellite, the removed debris satellite, cost 15 million. So
Right.
it's expensive, right? And that's just one item. So it's not easy to continue to, invest in these resources. And there's no incentive for these countries, right?
Yeah. There isn't really.
Yeah.
like like NASA. I know Japan and the European Space Agency did partner up for to like get the debris down or decrease the amount.
Yeah.
However, it's kind of like on the countries, as you said, to make those decisions by themselves.
Yeah. And like especially like we have to mention that the impact of these satellites. And so of course we send satellites into space to control a lot of waves, like radio waves and frequencies and such. And so in 1998, when
Yeah.
Pacers were still a thing, one satellite failed, and more than 90% of all the pagers in the world stopped working. So
Wow.
this is devastating, I guess. And of course, now we've moved away from pagers, we moved to phones and such.
Cell phone, yeah.
But looking at that idea, right, that one satellite can create such disastrous effects, we could see that like if one bit of space debris collides with our technology, with another satellite, or a piece of just paint hits something, right, that's not supposed
Right.
to, that can really devastate the amount of technology that we have here, the access to technology we have here on Earth. And then again, will create, economic issues, right? So on top of that, it's just very, very difficult for, us to kind of control that. And so there's this scientist called Donald Kessler, and he
Mhm.
imagined what is known as the Kessler syndrome. So he theorized that continuous collisions of these man-made objects in space will potentially destroy telecommunications and keep humanity trapped on Earth. So, I mean, I know there's been talk about humans going to Mars and looking abroad, of course, but with the growing amount of space junk and the, considerably almost infinite amount of space junk that can be created, right? Because if another satellite
Yeah.
combines with crashes another, right, that would that could create more space debris, which could break another satellite, which would create more space debris. So that would possibly keep us grounded here on Earth, and especially now because it's very difficult for scientists to kind of like move past the space debris that we have right now. It takes a lot to maneuver. So looking off of that, it's going to be increasingly more difficult to maneuver, the extraterrestrial space when it's so clouded, like I said before,
Yeah.
with the amount of space debris.
I think the problem of space debris isn't just limited to space travel, space exploration. You know what I mean? Like, it also
Yeah.
has an effect on Earth, like people, because, like, for example, if space debris contains a carcinogen, like I'm gonna talk about this in a second, but when it comes and re-enters back into Earth's orbit in the next 100 years, when like 70% of that low-flying Earth orbit space debris falls back to Earth eventually, it burns up in the atmosphere. However, when it burns up in the atmosphere, it releases all those chemicals into the atmosphere, potentially causing health problems and environmental damage and damage to the ozone layer. The list goes on, right? And
Yeah.
for example, uh, there was a case of what was it? Hold on, we're gonna have to cut this out.
Okay.
I need to find it. I literally don't know where it went. Where did it go? Where did it go? Found it. Okay. For example, there was a case in Russia for one of the rockets, the in Kazakhstan as well, which is near the this was near the Altai regions of eastern Siberia, and when the debris fell, it was from an old fuel tank, and it contained highly toxic fuel residue,
Hmm.
which is unsymmetrical dimethylhydrazine, or
Yeah.
UDMH, which is a carcinogen,
Hmm.
and it's harmful to plants and animals. And while efforts were made to contain the fallout from launches in a specific area, it's really hard to do that, right? Because it may fall, but it gets spread out so fast because it's falling and burning up in that atmosphere.
Yeah.
But um, Anatoly Kuzin, who is a deputy director of Khrunichev State Research and Production Space Center, which also manufactures proton rockets, hints that there's no correlation between reported illnesses and rocket launches. However, local testimonies from those literally affected from the fallout refers to a disproportionate number of cancer cases in the area, which many believe is related to the UDMH in the fuel tank debris.
Mm.
For example, in like 2007, 27 people were hospitalized in the Ust-Kansky district of Altai,
Mm.
which cancer-related complications, many of them citing the rocket fuel as the suspected cause. Like I said before, unsymmetrical dimethylhydrazine is a carcinogen and is
Yeah.
found concentrated in fuel tanks. And as uh, the Baikonur Cosmodrome in Kazakhstan, it like those Russian proton rockets,
Yeah.
as those debris fell and went into like the Altai regions where all these cases are popping up, it's really important to kind of question if there really is a correlation between this space debris burning up in the atmosphere and um, and the human health currently.
That makes sense. And so like another big thing of like management is that in the future, like several companies are planning like vast new groups of satellites called mega constellations. And so they're going to beam internet down to Earth. So like SpaceX is another big proponent. So SpaceX, Amazon with like Blue Origin, I'm not sure about Blue Origin, but I know Amazon is going to as well. And so they're planning to launch thousands of satellites to achieve global satellite internet coverage. And so SpaceX has already done so far. And so a lot of these internet providers, SpaceX is in these very remote areas, which is very helpful for, like people in rural areas or disadvantaged areas that can't really access internet. It's also very cheap, if not free. It's extremely cheap. So on top of that as well, if successful, there could be like an additional 50,000 satellites in orbit, but it also means that there's going to be a lot more collision of like avoidance maneuvers that will need to be done.
Yeah.
So on top of that, like in September 2019, the European Space Agency performed its first satellite maneuver to avoid colliding with the mega constellation. And so it's pretty unusual to have to like move like avoid active satellites, but it's kind of just to, prevent any possibility of a collision.
Mhm.
The first satellite maneuver is like happened, right? And so that's very
Right.
important because it's signifying that because of how polluted our space is, we have to resort to avoidances, and just because of that, it's continuously growing into this perpetual cycle of
Yeah.
if you're trying to fix it, you're just producing more space junk,
Right.
and the like creating like satellite maneuvers to avoid collisions uses more gas, or sorry, uses more fuel up. And so with the rocket fuel that's being used up, they or could not like survive as long as they normally would. And so there's negatives on both sides, right? But it's mitigation, with that, like by making sure that the satellites are removed from the orbit in a reasonable amount of time, like once they're no longer active. That's the best way that people can mitigate the problem of space junk in the future.
Right.
So it's very difficult for us to really find a
It
perfect
really
solution.
is. And like I know, as I mentioned before, Japan has partnered with the European Space Agency. So, like for example, they have a 6 month demonstration project with Astroscale, which is a company dedicated for space sustainability, for the world's first debris removal mission. Uh, However, it's a lot of this the details on this project. It's very hidden because a lot of it's not concrete yet. However, the ESA is working with the Swiss startup ClearSpace, and according to the ClearSpace website, it will be the first space mission to remove an item of debris of orbit. So, the mission is solely not for exploration, but for literally cleaning up remnants of all the pollution that we've had in space, and it's planned to launch in 2025.
Hmm.
The mission is being procured as a service contract with a startup led commercial consortium
Hmm.
to help establish a new market for in-orbit servicing as well as debris removal. So it serves multiple purposes, but the main point is debris removal. And I think what you said like it's really hard to solve, yes, which is why like in the future a lot of these are planned for 2025, 2030, 2050, all these like milestones set for the future and sustainability goals.
Hmm.
It's really hard to kind of be on track all the time for those things,
Yeah.
and it really forces us to rethink why we're doing this, how we're doing this, how we could do it better.
Yeah.
And it really just takes time, and it takes mass movement, even like though we like the status quo people like us don't really think, oh, we can't really do anything for the space stuff. Yes, you technically you really can't, but advocating for just more sustainability, for an increased awareness of the issue,
Yeah.
for like more local problems even can like kind of help that. Instead of like fueling more space exploration, while that is good, right?
Yeah.
We need to kind of refocus on our impact on not just Earth, but since we're going extraterrestrial, we need to focus on like other planet kind of impacts that we have. You said space junk has been found on the moon, which is literally millions of miles away from the Earth.
Yeah.
So all this like space junk can float everywhere else. We don't really know. A lot of this is muddied because it's not really been done before.
Yeah.
And all these solutions that have been proposed are a good step and are like steps in the right direction, but it really needs to be looked through a lens of not just economics, but ecology, sustainability, and kind of have it's because it's all interconnected, right? So we have to like look at it through a lens of not just progress, not just profits, but kind of look through a lens of how can we make this better? How can we for the future of humans exploring space or even space travel,
Yeah.
kind of have to just refocus on that and what will be the best for that.
Yeah. And on
Yeah.
top of that too, like just even talking about things on the moon, I found a little bit of like the stuff that's been left on the moon intentionally and unintentionally. And so it's a little funny. So just like some overall things. So three moon buggies from the Apollo 15, 16, 17 missions have been left. 54 uncrewed probes that have crashed or landed on the moon. 190,000 kilograms of material as well. And so the first spacecrafts and probes have been left on the moon by 1, 2, 3, 4, 5, 6, 7 countries. The USSR, USA, Japan, Europe, India, China, and Israel. And then some strange objects that have been left on the moon, which is a little funny to me, which is a golden olive branch, art by Andy Warhol, three golf balls, a falcon feather, a photograph of astronauts Charles Duke family. Those five are pretty interesting, I'd say. I think my favorite's personally the art by Andy Warhol, but
Yeah.
I don't know. I
Yeah,
think
and like,
it's
it's
interesting,
really
right?
interesting. Yeah. It's interesting, like especially with the bird feather.
Yeah.
I'm not an expert in extraterrestrial biology,
Yeah.
right? But like that's organic matter,
Yeah.
right? That's the proteins made by the bird to create the feather. I wonder how, like, if something like that could travel on a piece of space debris, like a piece of organic matter could, like, kind of like jumpstart life on another planet if it were to land there.
Yeah. Yeah.
Like, that's really interesting and some a different perspective that we can also take into
Yeah.
consideration as like a threat. Could be a threat. We don't know, right?
But that's for another episode, right?
That is for another
Yeah.
episode. Yeah.
But
Yeah.
yeah, I think it's
But
definitely important, like you said, to ensure that people are made aware of the issue. I think the best thing to do is just expose people to really what's going on, because it's a very underrepresented issue. Like it's not really talked about
Right.
a whole lot. And so just I guess publicizing that problem and kind of trying to get your your problems heard and your topics very well discussed with your local lawmakers, right? Because they have the power to give the funding to NASA, right? Most of NASA is funded, or a good portion is funded by the
Yeah.
government, if I'm
It's
not
government
mistaken,
funded.
right?
Yeah.
So, I mean, there could be kind of stipulations to the whole kind of to the funding of NASA, right? That can include, okay, you need to pollute less. You need to figure out solutions to, you know, kind of either depollute the extraterrestrial space or contribute less, be more sustainable
Right.
by this certain date, by 2025,
Yeah.
by 2030. And I think that's very doable. I think if we put our minds to it, because we got to space pretty quick, right? The second
Yeah.
we have an incentive, like Americans go for it, right? So
Yeah.
it's not just America, though. I think we need other countries to also step up
Of course. Yeah.
and
It's like
really
a high,
realize that this
like a
isn't
humanity kind of thing.
exactly, this is a humanity type of issue. This is not a
Yeah.
country type of issue. This shouldn't be taken into politics. This is something that
I
affects
agree.
all countries, right? If we ever want to have a chance of moving farther in our like beyond our world, go to Mars and stuff like that, we might eventually not have the possibility of it due to our the actions and of the people before us, right, of the generations before us.
Right.
So as the next generation and the current generation sitting in office, we need to implore them to regulate space. I mean, it's really that simple. We cannot have a continued pollution of this extraterrestrial space, because in the future we're not going to be able to really explore, right, with the Keenan effect, I believe, or the Kenner effect. We're not going to be able to really understand, sorry, it was Kessler, we're not going to be able to expand past the Earth, right? We won't be able to go to Mars. We won't be able to go farther, right, into places like Jupiter, Saturn, or even farther than our little solar system. Who knows, right? Because it's
Right.
the future, right? Things can become more complicated, right? Especially with the Hubble telescope or the Webb telescope. I think that's super interesting. Considering, right, like we're increasing the technology, and so I think there's eventually going to be a day where we're going to have some possibility to do something, but we're limited by the amount of pollution that we have. And so it's important that people implore their local lawmakers and the people in office to conserve and realize that this is an issue that affects everybody, and treat it as large as you, or treat it as important as you would any other, not only human rights issue but a conservation issue.
Right. Right. And I think that while it may not be like such a direct issue to you, like it could be, right?
Yeah.
Why not nip it in the bud
Yeah.
before it happens and becomes a critical issue, like the global climate crisis,
Exactly.
or what how the like the pandemic was, like all of the, like the issue, like in space, it can be stopped pretty quick if we not just if we either limit our space exploration, or limit our, and kind of like refocus on the earth, which I think is a pretty good idea. It's our only home right now. Instead of like turning to space, why not just like work on our earth now
Yeah,
and the
I agree.
problems that we have here, or work towards exploring space but more sustainably? Then I think that it would be good to like nip that problem there.
I agree as well.
And with that, our discussion comes to an end. We thank you for listening and hope you'll stay tuned for future episodes. Don't forget to follow the Pepper Podcast on Instagram, Spotify, Apple Podcasts, YouTube, and Google Podcasts. Thank you.
Thank you.